Today we're going to look at 3-2, day 2, and we're basically going to talk about residuals and residual plots. On your sheet is residual plot. It's a scatter plot of the residuals against the explanatory variables. The residual plot helps us assess how well a regression line fits the data. So basically, the x's will be the same. They'll be down here with the explanatory variable where it normally is, and then the y-axis will actually be the residuals. And then there's a line in the middle, which is the y=0 line. And then basically, the residuals will be marked above or below, depending upon whether they're over-predicted or under-predicted along this path. Something kind of like that. Obviously, I just made that up. But the residuals, the x's, and the y=0 line appear on all the residual plots. The next deviation of the residuals, so we talked about that yesterday, where that's the s, which approximates the size of a typical or average error of prediction or prediction error. So number 18 is, what is the purpose of constructing or analyzing a residual plot? So basically you're trying to determine if the data is linear. And the nice thing about a residual plot is that it magnifies the deviations of the points from the line, so basically the line of best fit or the regression line, making it easier to see observations and unusual patterns. Sorry, I got a new pen and it's kind of hard to write with. So it keeps sticking to the thing, so that's why it sometimes writes kind of messy. Sorry about that. So number 19, it says, what do we conclude if the residual plot shows no obvious pattern? So what if there is no obvious pattern? This is usually the most often thing that happens. So this basically means that the data is fairly linear. So a straight line, oh, this pen is driving me crazy. A straight line, that's what I get for buying a nice one. I should have just bought the crap at Walgreens. A straight line is an appropriate model. So basically that means that it's linear. So the graph itself is linear. And if we look at what happens if there is like a curved pattern or a distinct pattern to the residuals, then this means that a straight line is not a good model. So basically it means that it's not linear. The data itself is not linear. The scatter plot is not linear. So a straight line is not a good model. So there's basically two things we're looking for. When we look at a residual plot, if there is no distinct pattern, then we would state that the scatter plot would appear to be linear. If they give you the residual plot, you must address the residual plot. If they give you the residual plot and the scatter plot, you need to address both the residual plot and the scatter plot. The scatter plot will be addressed with the direction, strength, and form, and the residual plot will be addressed with the whether or not there's an obvious pattern, a distinct pattern or not. Alright, the next thing is the coefficient of determination, which is r squared. Leia, quit that. Annoying me, she's scratching her ear. So it's the fraction of the variation in the values of y that is accounted for by the least squares regression line of y on x. So basically r squared is equal to 1 minus SSE, which is the sum of the residuals squared, over the sum of the y hat squared. Really This isn't crazy necessary. You just need to know what this is. So the mantra for coefficient of determination is whatever the percent is of the variation in the response variable, right, the y variable, is accounted for by the, and then you talk about the relationship between the x and the y by the regression line of y on x. So, does there have to be a distinction between explanatory and response variables when calculating the regression? The answer for regression is yes. Okay? What about correlation? The answer for correlation is no. So there is a distinction when you're talking about regression. There is not a distinction when you're talking about correlation, because regression uses the units and you're talking about how y relates to x. So 21 says the correlation and regression lines only describe what types of relationship, and the answer is linear. So we always have to make sure that the relationship is linear first, so that then we can actually find what r is and the regression line is. All functions, whether they're linear or nonlinear, actually will have a correlation, like y equals x squared will have a correlation of 1, but y equals x squared is not linear. So we first have to make sure that it's linear before we start talking about the relationship between y and x. So 22, are correlation and the least squares lines resistant? So remember that the answer is no. If you have an outlier, it will change the correlation. Or if you have an outlier, which also may be an influential point, that could affect the equation or the slope of the least squares regression line, making it not resistant. So 23 is, does association imply causation? No, right, because of working variables. So there's two other definitions here. One is an outlier and one is an influential point. Outliers are usually in the y direction, so usually they're above or below the data. An influential point is most often in the x direction, so meaning that it's far to the right or far to the left of where most of the data lies. So 24 says, what is the difference between outliers and influential points? So an outlier tends to be in the y direction, so up and down, but staying close to the y-axis usually. Y direction. They tend to have large residuals. Okay, and an influential point usually occur in the x direction, and they tend to have small residuals. However, in order to be influential, it means that you've changed the mean, right? So the mean has been affected. The slant of the line of best fit, or the slant of the regression line, changes based on whether the influential point is in the data or not in the data. And something to note is that not all outliers are influential. So just because you're an outlier doesn't necessarily mean that you're an influential point. All right, and then we'll do number 17, finish that in class tomorrow, and then we'll look at 24. Is that the second 24? Yeah, so we'll look at the second 24. All right, so you can read the problem. Basically, it gives you the regression line, and then it says, would it be appropriate to use the regression line to predict y from x? And if you look at the residuals, you can tell it's a residual because it has the x's on the x-axis, but on the y-axis it has the residuals. You can see the y equals 0 line in the middle, just kind of like what we were talking about. So the answer is no, because the residuals have a distinct pattern. So if the residuals have a distinct pattern, then that means that you cannot use the regression line to predict y from x. So we'll just write this. All right, number 25. Number 25 is talking about when they already give us the data. Minitab is just a type of output. It kind of summarizes the data for us, a little computer program. So it says, what is the equation of least squares line? So if you look at where it says constant, The constant is the y-intercept. So in the column where it says coefficient, okay, that first number, negative 0.12608, is the y-intercept. And I would suggest that you kind of mark that on your paper so you don't forget. Where the explanatory variable is, it'll almost always have the word there, the actual explanatory variable, what it means. And then in the same column where it says coefficient, it will have the slope. So it's almost always like that. Depending upon what type of output it is, it'll either say constant or y-intercept, and then the second one will almost always be whatever the y variable actually is, an actual word for that value. So A, it says, what is the least squares equation? So first, remember that we have to write this in terms of the variables. So we need to figure out what the response variable is. So it says predict brain activity. So that means that the response variable is brain activity. So that's brain activity hat equals the y-intercept, so negative 0.12608, plus the slope, 0.060782, times the x variable, which is distress. I ran out of room, but you would write distress there. Okay, and that's the answer. You need to make sure that you have the variables in the problem, okay? We talked about that earlier. All right, on the last page, talk about what percent of variation in the brain activity among subjects is explained by the straight line relationship. So that basically is the exact words for r squared. So if we look at our paper, go back to where the data is, there's two different types of r squared on that bottom row. It says r-sq and it says r squared adjusted. We always use the r squared and not the r squared adjusted. So our r squared is 77.1%. Right, and then if we go on to C says use the information in the figure to find the correlation between social distress and brain activity. So if r squared is 77.1, then r is equal to the square root, turn it into a decimal, 0.771, which is 0.8781. How do I know if it's positive or negative? Well, you look at the slope. So since the slope is positive, the correlation is also positive. If the slope was negative, r would be negative. Last, D says interpret the value of S. So remember the S is the standard deviation of residuals. So it's the amount of typical error, the amount of predicted error, or the average error. All three of those things can be used. So it's the typical error when using the line to predict activity in the brain. It always is the y-axis, or the response variable, is about 0.025. Okay, so your assignment is actually going to change a little bit from what's written there. It's 49, 54, you don't have to do 49 anymore because we did that earlier, 54, 58 through 61, but on 59 only do A and B, and then we'll do number 63, and then 71 through 78, all these are multiple choice, so they're pretty good practice problems. And so that's what we'll work on class tomorrow. If you're not going to be there or missed, then that's definitely the assignment that you want to do.